It's that time of year again. Life on Earth has survived another year, and the planet still turns. In the spirit of the holidays, it is time we take a look back on the last year and paleontological discoveries. I missed plenty of them, and you definitely did as well. This year we found out about crazy new sauropods with neck spikes, which could make even the most anti-establishment cyberpunk jealous. There was a fast-paced, dune-drifting theropod roadrunner from South America, and 2 new primitive members of the Tyrannosaur lineage. A smorgasbord of other interesting creatures was described and given their respective place among the grand history of life on Earth. So let's not delay and learn about all the primordial goodies of the past year. This year's PaleoRewind collaboration crew features Aydin from Kikizilla 101, Spenser from Cretaceous Cast, David from SpinoDudeReviews, Henry from Henry the Paleoguy, Gibson from BionicleSaurus, Ben from Benji Thomas, Matthew from MatthewTheDinoKing, Nature's Compendium, Camosaurus, Terrible Dactyl from Jurassic Plastic, Trey from Trey the Explainer, and Omega Pictures. All of these wonderful folks produce some real quality content, and this video wouldn't exist without them. Check them out when you get a chance. Links in the description.
January. Proto-Ichthyosaurus gets a CT scan. Computer tomography technology is the kind of stuff usually reserved for the medical sciences. It's a hulking machine which uses an X-ray to cut virtual slices through an object. A computer takes in data recorded after the rays come out to the subject and pieces all of the slices together into a 3-dimensional image. Utilising the appropriate software, you can see the insides of the 3-dimensional object without having to cut into it from the outside. The uses for the tech in the medical field is 1,000-fold, but what it can do for a human subject, it can also do for a fossil. CT scans have been used before for fossils to see structures within remains you may not want to physically cut into. It also allows you to analyse and to describe the morphology of the fossil remains without removing enormous amounts of matrix that may be detrimental to the specimen. Dr. Dean Lomax, Dr. Laura Porro and Dr. Nigel Larkin use computer tomography scanners to take a deep dive into the skull of a massive marine reptile which had been discovered in the 1950s. The 80cm long snouted skull belonged to the fish-like ichthyosaurs. Most fossils are not found in articulation, nor in perfect 3D, but the skull of what the researchers distinguish as Proto-Ichthyosaurus prostacylix certainly was. The 3D scans pinpointed where the specimen had been approximated with wood and clay, which highlights how paleontologists and museum specialists can use advanced imaging techniques on historical specimens to reapprise previous assumptions. Eretmorhippus gets ahead. The aftermath of the Permian mass extinction continues to provide countless examples of organisms adapting new strategies to survive in the blank new world. Just one more involves a redescription of a previously discovered marine reptile from China. Eretmorhippus caraldongi is a member of a group of critters called hooposuchids. These marine reptiles were generally small to medium-sized with a barrel-shaped torso, 4 broad but stubby flippers, a long tail which may have had a fin at the end, and a small head topped by a thin snout. The new fossils reveal that this strange creature had the head of a platypus. The skull has a hollow space in its expanded snout, which mirrors the structures seen in the skull bones of the modern monotreme platypus. It is due to the morphologic similarities between the two that the researchers suggest it may have also been an analogous structure with similar electrosensory abilities. Eretmorhippus was probably grubbing around the sediments of the shallows for worms, crustaceans, and other creepy crawlies to slurp down. Its awkward body with its single row of backplates was not particularly adept at swimming, so a lifestyle of ploughing your head around in the dirt to look for food makes sense. If it had the electrosensory capabilities akin to something like the platypus, as the discoverers suggest, it may have used it to sense for prey underneath the sediments at the bottom of the sea, a useful food detector to be sure. The future is now, you fossil. How much we know about extinct organisms and how much we do not know is a vast chasm we often take for granted. Something as simple as locomotion is very difficult to fully prove for any given fossil taxon. It has been hypothesized how fossil animals moved based on their living relatives, vague and inexact correspondences with skeletal form and musculature function, and measurements of fossil trackways which can be inconclusive. A group of European scientists has conducted an experiment as a first in attempting to quantitatively prove the locomotion of an extinct stem amniote. It has been suggested in the scientific literature that advanced locomotion on land, the efficient weight-bearing support adaptations we see in modern tetrapods, was instrumental to the takeover of terrestrial habitats by the tetrapods. A robotic model created from the fossils of Orobates pubsti, a stem amniote known from a near-complete skeleton in association with fossil trackways, opens a window into how the tetrapods adapted to a terrestrial existence. In the study, the bones were modelled in the computer, printed out and constructed with the accompanying robotics that are beyond me, and programmed into computer language which could adjust the gait and speed of the robot to mimic what can be assumed from the trackways.
February. A sauropod bad hair day. Dactylosaurids are a group of sauropods known from the early Jurassic to early Cretaceous periods of across the globe. They are unique in their uncharacteristically short necks and twin vertebral spines starting behind the head and continuing down the back. Amargasaurus is most widely known for its backwards oriented neck spines which were rather long, but Brachytrachelopan is another example known for the even stranger adaptation of an incredibly short neck, 40% shorter than its relatives and the shortest of all long-necked dinosaurs. A new member of the group was described, which took the general idea of the long neck spines of Amargasaurus and answered the immediate question of, what if they went the other way? Meet Bahadosaurus pronuspinax, a sauropod with a twin set of forward-facing neck spines. Its remains were very fragmentary with only the skull, one whole vertebra and pieces of other neck bits uncovered in Patagonia. The descriptors suggest the forward-facing spines of Bahadosaurus were used in a defensive role, but the exact function remains mysterious. Don't be morose, it's Moros. The lineage which gave rise to the bulky, bone-crushing tyrants of blockbuster fame is a little bit of a murky mystery. Fragmentary remains of a deer-sized tyrannosauroid from Utah gives new insights into the evolution and diversification of the tyrant dinosaurs. Moros intrepidus, named after the being of impending doom of Greek mythology, is characterized by long gracile legs and short recurved teeth which lent it an edge when dealing with small prey items. Its remains originate from rocks dated to about the very beginning of the late Cretaceous period, and they show characteristics which are found in tyrannosaurs and tyrannosauroids that lived in Asia before and during the reign of the Harbinger of Doom. A new noggin. Siamodontids were a group of marine reptiles which were around during the Triassic period. They are derived from the placodonts, which were a group characterized by barrel-shaped bodies, huge flat grinding teeth, wide triangular skulls, and paddle-like limbs. They were what you'd get if you spliced manatees and crocodiles. The Siamodontids took this body plan and adapted it to include traits of the turtles, with carapaces and plastrons keeping their insides safe from the can-opener jaws of early ichthyosaurs and nothosaurs. Unlike the turtles, their way of protecting themselves included a boxy shell over their torsos, with some lineages including a second shell over their pelvises and the base of the tail to allow for more movement. A new species of an already known genus, Siamodus, was described out of Chinese rocks dating from the Carnian stage of the late Triassic period. It differs from the previously described European species by having an enormous skull relative to its body, huge openings in the top of the skull, and the lack of a bony shield over the pelvic region.
March. Hamming it up with Iberian pterosaurs. The Iberian Peninsula, consisting of Spain and Portugal, has a rich fossil record which has started to become more heavily endowed in data within the last half-century. Aside from the terrestrial dinosaurs of the late Jurassic and early Cretaceous periods, other forms of life are a bit more scarce. Pterosaurs are especially underrepresented in the Spanish strata. A new pterosaur from Spain, Iberodactylus andrewi, presents part of the skull of a pterosaur with affinities to the Chinese Hemipterus. Such close affinities with the Chinese pterosaur told the researchers a new family was in order, and they named Hemipteridae as a group within the Anhonghuiria, a group of pterosaurs known for their long snouts, rounded snout crests, and enormous wingspans. Great Scott! He's huge! Scotty the Tyrannosaurus, first uncovered in the early 1990s, has finally been uncovered and described. The remains of the incredible tyrant dinosaur suggest that it may have been the largest and oldest Tyrannosaurus rex so far discovered. Dr. Phil Curry, one of the lead researchers of the analysis, found that the individual was pushing 30 years old at death, would have weighed 8,800 kilograms in life, and showed presence of paleopathologies in the skeleton which tell us Scotty lived a rough life with many broken bones, gouges, and scrapes which it was able to survive and heal from. The weight, size, and age of Scotty means it is now considered by many to be the oldest and largest Tyrannosaurus rex yet known, beating the previous record holder, Sue. However, some objections and critique to the study means the title of who's bigger and meaner has yet to be fully settled. A convoluted mess of Convolusaurus. Back in the mid-1980s, a bone bed was discovered near Proctor Lake in Comanche County, Texas. The bone bed withheld the remains of around 30 individuals of two-legged Hypsilophodonted-like ornithopods. It took nearly 40 years before the remains would see official scientific classification and analysis. Before now, the remains had been composited into 3 skeletal mounts and put on display in 3 Texan institutions where they are labeled as unknown Hypsilophodontids, but now they have a name, Convolusaurus murray. Though these critters were from one of the most overlooked group of dinosaurs, the number of individuals uncovered from nearly every ontogenetic stage gives one of the best looks at these swift bipedal herbivores. I like my eggs sunny side up. A few years ago, the news broke of the scientific discovery of a type of tissue by the name of medullary bone within the bones of a Tyrannosaurus. Medullary bone is a tissue which develops within the bones of female birds which are getting ready to lay their eggs as an extra reserve of calcium to help produce the eggshells. If you were to find such preserved tissue within the remains of an extinct organism, it would provide a sort of gender reveal for the individual organism in question. A freshly described anornithine bird from early Cretaceous China preserves both traces of medullary bone and an egg within the body cavity, which gives us the best correlation between medullary bone and reproductivity in non-bird type birds, as well as potentially the non-bird dinosaurs as well. Eva Maya schweitzerae is the name of the beautifully preserved two-dimensional skeleton of the stem bird, and ground sections revealed abnormal eggshell proportions, and multiple eggshell layers best interpreted as a multi-layered egg resulting from prolonged oviductal retention. I presume this means the bird had the egg inside of it for too long.
April. King of the Lion Kings. Everyone who's familiar with ancient beasts has probably seen or heard of the Walking with Beasts series, a worthy follow-up to the Walking with Dinosaurs BBC series. One of the more memorably terrifying predators reconstructed in the show was the hyenodon. Hyenodonts were a group of mammals which were unrelated to the hyenas, dogs, cats, or all other members of the carnivora order. They were a distinct lineage of bone crushers and powerfully built carnivores likely adapted for taking down powerful prey items. A new hyenodont from Africa represents one of the largest ever found. Simbacubwa kutokafrika was so large its lower jaw alone was larger than the entire skull of a modern lion. It has been estimated it could have reached 1,500 kilograms or 3,300 pounds, the size of a small rhinoceros, and larger than the modern polar bear. Its teeth suggest it was a specialist predator of large megafauna like rhinos and elephants. The goby never holds back. Most folks tend to overlook the hadrosaurs. Many of these beaked herbivores were without crests and spines, and looked plain and homely compared to some of the more extravagantly adorned members of the Dinosauria. However, They were important parts of their ecosystems, and were amazingly unique in how they developed ways of crushing, chewing, and processing their food. Normally, the discovery of yet another outwardly bland ornithopod would not raise many eyebrows amongst internet-dwelling paleontology nerds, but I feel like Gobihadros mongoliensis here ought to. The remains of this critter were so well preserved that the holotype consists of a vast majority of the skeleton, skull and all, as well as a nearly three-dimensional, symmetrical and uncrushed skull. To top this off, Gobihadros is one of the more basal forms known, and has been placed outside of the Hadrosauridae family. Tentacle Nightmare. The Silurian period, Lagerstätten of Herefordshire, England, is a bed of limestone which has preserved many different types of organisms which have escaped fossilization in most other rock layers. A three-dimensional fossil has been described from this layer of rock, which represents an organism more closely related to sea cucumbers, but retaining some features seen in the sea urchins. The critter was called Solacina Cthulhu because its body consisted of a ring-like structure with a bunch of tentacles surrounding it, like the cephalopodal behemoth of the Lovecraftian cult classic. Like other fossils from Herefordshire, Solacina Cthulhu was studied using a method involving grinding it away, layer by layer, with a photograph taken at each stage. This produced hundreds of slice images which were digitally reconstructed as a virtual fossil. To that end, a 3D model was produced, allowing us to get an incredibly complete look at the little terror of the sea bottom.
May. Hello random ladies and gents, I'm Omega from Omega Pictures, and I'm Click from the same place. And welcome to the May segment of this year's PaleoRewind. We're so happy to be a part of this, and we're even happier to fill you in on the discoveries from this past May. Coyote and Roadrunner team up. The tattered remains of a theropod dinosaur were excavated nearly 20-some-odd years ago in the Zuni Basin of New Mexico. Dr. James Kirkland and Douglas Wolfe of the White Mountain Dinosaur Exploration Center wrote about this discovery in their description of another dinosaur, the early ceratopsian Zuniceratops, but did not formally describe the creature until now. After years of going under the various unofficial tags of Zunicellurosaur, Zunityrannosaur, and Zunityrannus, the coyote-sized theropod has finally been given the name Suschityrannus hazeli. The predator is now confirmed to be an early tyrannosauroid and represents the intermediate between the oldest, smallest tyrannosauroids and the gigantic, last surviving tyrannosaurids. Before it was confirmed to be a tyrannosaurid, the leg bones and elongated snout of Suschityrannus were thought to be a dromaeosaurid, and after that, it was thought to be a Basilcellurosaur, and as a result, the creature was reconstructed as a dromaeosaur and a Basilcellurosaur in the television documentary When Dinosaurs Roamed America. The presence of Suschityrannus in the Zuni Basin not only fills the gap of the predator niche, but it adds a new piece to the puzzle regarding the coevolution of ceratopsians and tyrannosaurs, representing a key predator-prey relationship spanning as far back as the Jurassic to the very end of the Cretaceous. There's more than one way to wing it. The evolution of flight has long been an object of great discussion in scientific literature. In recent years, it has been shown that flight is an ability which has had many variations in both form and function. Pterosaurs were a group of ornithidiran reptiles that modified their fourth finger to support a membranous wing. Avian theropod dinosaurs adapted their arms to support well-anchored asymmetrical flight-capable feathers. And of course, the mammalian bats have adapted a membranous wing spread across their 5 digits. Another group adapted a different method by incorporating their manual digits and a splint of bone modified from the wrist bone into a membranous wing, which may have had the additional sample of feathers. Yi Chi broke headlines as a dragon or wyvern-like non-avian theropod dinosaur, which may have used its wings to glide from tree to tree. But many scientists were skeptical of whether or not the fossil represents a true membranous wing, or just a weird happenstance of seeing things that aren't there. A new member of this group, Ambopteryx longibrachium preserves a fossil which is less open to interpretation in showing a membranous wing supported by a wrist bone and digits, as well as more data on the diet of this critter, which suggests it may have been an omnivore. Free Willy, except not. A new step in the evolution of mosasaurs has been described based off of a partial skeleton from the neck to the pelvis. The remains included an incredibly well-preserved right forelimb, which gives a good impression of where it sits in its family tree. Fortunatosaurus crambergeri was an Aegyalosaur, a group of early mosasaurs which started to adapt to a more marine way of life by elongating the body, shortening the limbs, flattening the paws into a more flipper-like shape, elongating the tail, and dorsoventrally expanding it into a fin to propel the animal through the open ocean waters. Fortunatosaurus had limbs capable of moving on land, but were obviously more paddle-like than earlier forms like Aegyalosaurus or Compendium. What the find does not tell us is whether or not the mosasauroids originate from a snake-like ancestry, a monitor lizard-like ancestry, or some weird back and forth from land to sea to even a fossorial existence. Nevertheless, it adds a key piece to the puzzle of mosasaur evolution and their success.
June. King of the trilobites. When it comes to the Cambrian period, trilobites are the first and best thing to come to mind. There's a good reason for that. They're charismatic in their resemblance to horseshoe crabs and roly-polies, and are so well represented in the fossil record due to them being one of the first major groups of organisms to secrete minerals to produce hard outer shells for protection. The largest of the trilobites were the Isotolus rex, coming in at around 28 inches or 72 centimeters in length. A new species of an existing genus of trilobite, Redlichia rex, has been described from Lower Cambrian Emu Bay Shale of South Australia. So now we have both an I-Rex and an R-Rex, because scientists think Rex is a cool species name thanks to T-Rex. And honestly, they're not wrong. Redlichia rex was unique in having 3 to 4 spines on some of the segments of the axial lobe in the center of the animal's back, as well as its large size of 25 centimeters or 10 inches long. Hyenas in the Arctic. Hyenas are incredible animals. They appear like something out of the Ice Age. Primitive beasts capable of rending flesh and bone without hassle, and crunching through even the toughest of skeletal material to get to the nutritious bone marrow within. Contrary to this observational prejudice, hyenas originate from times much earlier than the last glacial maximum, are highly intelligent pack hunters, and show embarrassing amounts of affection for one another, and even humans, given the right circumstances. Recent data collection has found a few fossilized teeth from the Pleistocene hyena genus Chasmoporthetes, among other fossils in the old Crow Basin of what is now the Yukon Territory of Canada. This rare find extends the geographic range of the genus northward by more than 4,000 kilometers or 2,500 miles, and may suggest the animals may have been more prevalent in North America from its arrival to the continent during the Pliocene and extinction during the Pleistocene. Worldwide big birds. Earth has played host to a variety of giant flightless birds throughout its natural history. Moas from New Zealand, Dromornithids, and the modern emus and cassowaries of Australia and surrounding islands, the elephant birds of Madagascar and mainland Africa, and the forest rakids of South America and the American South. But none have previously been described from Europe. That is, until now. Remains of a gigantic extinct relative of the ostrich have been described from the early Pleistocene epoch of Georgia, which class it as about 450 kilograms or 1,000 pounds, and 12 feet or 4 meters tall. Pachystruthio demansiensis may not have been entirely closely related to modern ostriches, but it very likely interacted with our ancestors. Non-avian roadrunner. Noasaurinae is a group of theropods, which make up the only other group next to abelosauroids that descended from the Ceratosaurus of the Jurassic period. They were quite unlike any other group of theropods in having tiny forelimbs, long legs, and mouths bristling with an array of teeth varying from recurved fishhooks to pennant insect snatchers. A new one described from skeletal elements found in Cretaceous rock of South Brazil present another bizarre form, which has been named Vesperosaurus piranhiensis. The critter had a similar overall appearance to what is known from relatives Velociraptor and Noasaurus, but differs in a foot that has an elongated middle toe, with digits 2 and 4 shortened and held up off the ground in neutral pose. The researchers suggest the animal may have been a dune runner, using its long middle toe to skip across the sands, and the 2 side toes as rudders and brakes to zip around the deserts of Mesozoic Brazil.
July. Flight is but one way to conquer the world. Archaeopteryx was once considered the first bird, but since the general acceptance that birds are dinosaurs has been settled into the collective psyche, that title, and what that title means, has changed a lot. Plenty of non-avian line dinosaurs that appear even more bird-like than Archaeopteryx have been uncovered, as well as plenty of forms that straddle the lines between Archaeopteryx, anti-ornithine birds, modern birds, non-avian dinosaurs, and Maniraptorian dromaeosaurs. One such creature was described from material uncovered from the late Jurassic Morrison Formation of Wyoming, and represents a decidedly flightless troodontid which has been diagnosed Hesperornithoides mesolleri. It is known from most parts of the skeleton and had arms nearly as long as its legs. Its affinity with other known feathered non-avian dinosaurs lends the animal to be reconstructed more bird-like than anything else. Bird is the word. Amber finds are the best. They're one of the few possible ways to get literally a snapshot of the insides and outsides of an organism. When it comes to amber fossils, those trapped and preserved within the candy-like substance are invertebrates and plants, or very small vertebrates like lizards and frogs. But recently, specimens of amber containing pieces of avian and non-avian dinosaurs has been described. A new one of these specimens contains the remains of a new inanthornine bird from the Cretaceous Myanmar, which has been named Electroornis chingwengi. The amber specimen contains the bird's leg and flight feathers, which show the animal had an extremely elongated third digit, the middle toe. The researchers suggest the bird used this elongated toe in foraging behavior, perhaps as a fishing line to snag insects from beneath the bark of trees like today's eye or the bills of the modern woodpeckers. Eagle-crested beast. Reclassifying things is fun, especially when you have a museum collection just waiting there, asking to be questioned. That's just what happened to the remains of a hadrosaur from the late Cretaceous Agoka Formation of Texas. The remains of the hadrosaur suggest to those that took a second look that the animal was unique enough to belong to a new creature, and thus it was named Achilaris palamentis. The Cretasauran-like hadrosaur had an inflated nasal crest and shovel-shaped beak, which has been suggested to have been tipped in a beak which helped the animal to scoop massive amounts of vegetation into its mouth. Killer bottom-feeding Millennium Falcon shrimp. As if the Cambrian couldn't get weirder, it continues to impress with out-of-this-world creatures that truly belong to science fiction. A new member of the Radiodonta order, which includes Anomalurus, has been described from the world-renowned Burgess Shale of British Columbia. The fossils preserve the outer appearance of a creature that looks like you squished an Anomalurus flat, mixed in some horseshoe crab characteristics, and turned into a filter-feeding predator. Cambrorastor phallicus would have used its round shovel-like head covering to plow through sediment to stir up any hidden snacks that it would probably filter out through its branched head appendages, and slice and dice it with its ring-like pineapple-shaped mouthhole. Oh, and it was nearly a foot long, too, which is a behemoth for the Cambrian, when most things were only measured in a few centimeters or inches.
August. Chillin' in the green. The forests as we know them, spread throughout the world even with the onslaught of man, are incredible feats of nature and evolution by natural selection. Despite their sessile existence, they have evolved just as the comparatively lively animal life on land, sea, and air. Just when the first forest started to cover the land is an interesting topic, because the fossil record only holds so much, and a recent discovery adds a new locality that would have represented patches of lycopsid forests strewn about the land of Devonian period China. Lycopsids are an ancient lineage of vascular plants which came in shapes similar to palm trees in the Middle Paleozoic era, but are now mostly relegated to the club mosses. Researcher Dr. Deming Wang said, "The large density as well as the small size of the trees could make Xinhang Forest very similar to a sugarcane field, although the plants in Xinhang Forest are distributed in patches." A Herculean feat. When it comes to giant flightless birds or bizarre lineages of reptiles and mammals, New Zealand has much of the world beat. That's due simply to the fact that it's an island. Islands play host to many unusual lines of evolution due to large pressure by natural selection to adapt to living with less resources. Sometimes organisms increase in size if they were small-bodied before colonizing the island, as they now have more resources, or they decrease in size if they were large-bodied before the colonization to account for less resources. New Zealand never received large amounts of mammalian Robinson Crusoes, and instead was home for many groups of birds during the Cenozoic era. New Zealand had the large Haast's eagle, the moa birds of varying heights, sizes, and niches, and the pinched-beaked adsbills. A new fossil find uncovers another such enormous flightless bird, Heracles inexpectatus. Unlike the other large avians of the island, Heracles was a parrot, a Miocene relative of the modern kea, and was described off of some leg bones. Despite the paucity of remains, the descriptors were able to reconstruct it and its relations to the modern kea due to characteristics seen within the leg bones. The creature may have stood as tall as a meter, or 3 feet, and weighed in as much as 7 kilograms, or 15 pounds. World-traveling thagomizers. Stegosaurs are an interesting group. They are known mostly from the northern hemisphere, and most seem to have had relatively long necks, long tails, and of course the spines, plates, and thagomizers that protected them from attack. Some vertebrae of a stegosaur have been described out of Middle Jurassic Morocco, which suggests that stegosaurs were more abundant in the southern hemisphere than previously thought. Named Adracticlet baolafa. This stegosaur, known from vertebrae, came up as a close relative to Miragaia and Dacentrurus when placed into a phylogenetic analysis. Brazilian repto-giraffes. The Brazilian fossil site which brought us the tapejarid pterosaur Kaiwajara in 2014 has brought forth another pterosaur, Caries dracon wilsoni. The rock record of this formation, the Goiás Formation, suggests this area of Brazil was a desert. Caries dracon is recognized from specimens of juveniles and subadults, and has been characterized as an asdarcoid pterosaur by its descriptors, carrying a long pointed beak with keels on top and bottom. Spanish spines. Spinosaurs tend to be most often preserved as bits and pieces, and it can be somewhat easy to see why. Despite the group's affinity and adaptations for waterway living, the remains are never as complete as one would expect from something living in and around water, which is the major nucleus for fossilization in the first place. It probably has something to do with how large they are and the speed of flow in the rivers and tributaries they likely inhabited. After one of these frying pan heads died, their carcasses would have been torn apart by predators and scavengers, and the bones taken up by the current and scattered downstream, leaving a very incomplete Spinosaur to become fossilized. New remains of a Spinosaur from Spain are just another example of this phenomena. Vallibonavenatrix cani has been described from a set of incomplete vertebral elements and represents a branch of the African and Asian Spinosaur lineage, which made its way to Europe, providing evidence for a land connection between the two continents before the Aptian stage of the early Cretaceous.
Even the king needs AC. A recent study on the skull openings of a bunch of Archosaurian reptiles has suggested that previous reconstructions of the musculature within the skull of dinosaurs and Archosauromorphs are incorrect. Researchers took infrared video and images of living crocodilians. They observed that these archosaurs had a small, circular area on top of the head, which helps them regulate their internal body temperatures when they are basking. These small areas on the outside of the skull are capped with deposits of blood vessels and fatty tissue directly underneath the skin. Below these deposits of highly vascularized tissues is the musculature which connects to the lower jaws through the underside of the skull. The holes are called dorsotemporal fenestrae. One of the telltale signs that these holes contain the highly vascularized tissues in living crocodilians is a little shelf of bone which sticks out from the rim of the dorsal temporal fenestra, called the frontoparietal fossa. This same shelf of bone is found in the skulls of many other extinct lineages of Archosaur, including the dinosaurs. Among dinosaurs, the largest openings in the skull, with the biggest attachment points for vascularized tissue, have been found in tyrannosaurs. They likely used this regulatory device to help them lose heat and cool off when it was hot, and gain heat and warm up when the temperatures were chilly. Lizards swim abreast. Mosasaurs were the rulers of the oceans during much of the Cretaceous period. Many could grow to 30 feet or more in length, with some reaching up to 60 feet, and very old individuals could possibly even surpass that. Their primary mode of locomotion involved the use of their powerful fluked tails. Or was that their primary mode of locomotion? A new study took a look at the biomechanics of these predators and found that they swam in a manner unlike anything alive today. Instead of relying only on one mode of movement through water, tail-powered cruising or an ambush-worthy burst, the mosasaurs did both. The pectoral girdles of mosasaurs were incredibly large, and the bone structure of their muscle attachment sites was found to be asymmetrical. This all suggests that these animals had a strong breaststroke. Put together, the results of the study suggest mosasaurs were complex creatures which used a combination of different swimming techniques to quickly cruise over open waters and to burst after fast-swimming prey items with extra help from the front fins. Weeb-crested duckbills. Japan has been connected to the Eurasian continent for hundreds of millions of years, only splitting off during the last 23 to 15 million years. This means its rich fossil record throughout the Paleozoic and Mesozoic eras represent faunas which also inhabited what is now Russia, China, and the Koreas. That being said, a new member of the Hadrosaur group has been described from incredibly complete remains, Camosaurus japonicus. Though not named after the award-winning Kill la Kill anime series, Camosaurus is still rather interesting in just how complete the remains are, as they include nearly the entire skeleton. Camosaurus was an Edmontosauran, which means it was one of the all-around practical, no-nonsense duckbill builds, without any super fancy head crests, nor spines or complicated ridges down the back. The lack of bony crests does not mean the animal couldn't have had soft tissue crests, like what was found on an individual of the Edmontosaurus genus. At least they didn't name it after Fukui, Japan. I was getting tired of the FU-sauruses. Frigid flyers. Ajdarchids are some of the weirdest creatures to take to the air. They were basically reptilian giraffe bats with the face of a stork. Having yet to star as the main antagonist of any sci-fi dinosaur film is frankly criminal. Quetzalcoatlus, the poster child of the group, has been known since the 1970s, and bones found all over North America were given this name. Only when new material of other Ajdarchids had been discovered in decades since has the true diversity of these terrifying beasts been revealed. Remains of a large Ajdarchid pterosaur from Canada, previously attributed to Quetzalcoatlus, have been reassessed as belonging to something different, and thus were given the name Cryodracon boreas.
So, starting off the month of October, a new species of pterosaur was published, Pterodracolentoni. This animal lived during the Cretaceous from 104 to 92 million years ago. Pterodraco was found from the Winton Formation of Queensland, Australia, which is also home to a variety of Australian dinosaurs, including Australovenator. Pterodraco is a member of the ornithocheirid pterosaurs, and is the most complete species of pterosaur found in Australia. Almost all ornithocheiroids are thought to have been aerial fishers, and most species live near marine coastlines. Pterodraco, on the other hand, inhabited more terrestrial regions, and may have hunted in the rivers and lakes instead. Next up, a new and exciting species of Carcharodontosaurid was finally published, Siamraptor suwati. The animal lived over 113 million years ago during the early Cretaceous and was excavated from the Kok Kruat Formation in Thailand. This makes the raptor the first definitive named Carcharodontosaurian species from Southeast Asia, and the discovery showed how Carcharodontosaurids were more widespread across Earth than previously thought. Returning back to the land down under, the SVP meeting of 2019 was held in Australia. During this time, evidence supporting the possibility of sauropods having beaks was presented. While this was a previously held idea based on Camosaurus specimens, several more sauropod skulls have been examined. Evidence in favor of sauropods having beaks is based on previous analysis on Camosaurus, followed by more recent examinations of other sauropod species such as Europasaurus. For starters, many sauropod skulls with teeth have them preserved in the exact same position that they would have been in life, without additional bone surrounding them. Wear patterns on the sauropod teeth also suggest that they were embedded in beak-like tissue. Furthermore, some species were found with pits in their skulls that would have allowed for blood vessels to support beak tissue. And concluding this month, new findings from the Coral Bluff site near Colorado Springs were finally published. The discovery includes well-preserved remains of at least 16 mammal species, as well as many turtles, crocodilians, and plants that lived during the first million years after the extinction event which wiped out the non-avian dinosaurs. During this time span, there were significant periods of warming that allowed for drastic changes in floroddiversity. The diversification of palms, followed by the arrival of protein-rich seeds, coincide with the gradual growth of mammal sizes. In short, as plants continue to diversify, mammals continue to grow to accommodate these new niches. And as the saying goes, life indeed found a way.
November. Hornless shelfhead. Leptoceratopsids are a group of hornless horned dinosaurs which diverged from the main ceratopsian line and coexisted with their bigger cousins throughout North America and Asia, with their diversity in Asia specifically far surpassing the known diversity of the true ceratopsians. They never got much bigger than a large pony or cow, and many were the size of a dog. New remains of a leptoceratopsid from Canada extend the known range of these little shelfheads to cover the entirety of North America. Pterosaurus sustatensis was described off of fragmentary remains consisting of pectoral girdles, the front and hind limbs of the left side, and the right foot. You need a coat when it's cold. Dinosaurs had feathers, and birds are dinosaurs. This is well established. What isn't as well established is the hard evidence that feathers can be found in more than just a handful of dinosaur groups. A new assemblage of fossilized feathers from Australia outlines how the dinosaurs and ancient birds living in the once polar regions of Australia were adapted to the comparatively frigid temperatures of the southern continent. The dinosaurs we saw brave the ice and snow in Walking with Dinosaurs would have lost all their heat and died during their first winter. But thanks to this new fossil find of primitive and complex feathers, it is very likely that they would have been covered in feathers to help insulate them from their polar environment. The descriptors of the feather fossils found there may be a presence of eumelanosomes and residual patterning within the feathers, which could give an indication of the colors and patterns the animals would have possessed in life. But most of them were uniformly the color of the rock in which they were found. Shark-toothed theropods ruled South America. The Dinosaur Planet episode Alpha's Egg recounted the life and times of Saltosaurus, and within the episode the primary antagonists were the Carcharodontosaurids. The makers of the program based these dinosaurs on unknown remains at the time, which were thought to belong to the massive shark-toothed theropods. However, it would later turn out that the remains belonged to the pointy-snouted, meat-hook-clawed Megaraptorans. But now it seems there were plenty of other Carcharodontosaurids in South America prior, during, and after the time of Saltosaurus, so their inclusion in Dinosaur Planet wasn't totally crazy after all. Lajos venator ascheriae is a newly described Carcharodontosaurid from Argentina which has been named on the basis of both vertebral and cranial elements. Lajos venator also happens to be one of the oldest known Carcharodontosaurids in South America, and would have given the sauropods at the time a run for their money. Lebanese pterosaur markets. The pterosaur train keeps rolling as a new, nearly complete skeleton of an istodactyliform pterosaur was described out of the late Cretaceous deposits of Lebanon. Mimodactylus lebanensis comes from a layer of rock abundant in fish and invertebrates but virtually devoid of tetrapod fossils. It is the most complete pterosaur yet uncovered from Africa and increases the known diversity of the continent's flying reptiles, as well as suggesting the presence of a new group of pterosaurs, the Mimodactylidae.
December. Long necks of Ecuador. Ecuador is not the country high on anyone's mind when thinking of fossils and prehistory. However, it has played host to discoveries of the Cenozoic era, with the majority of fossil faunas uncovered belonging to the megafaunal groups of ground sloths, giant armadillos, horses, and mammoths. A new discovery within rock layers dating back to the Upper Cretaceous of southern Ecuador yields a small saltosaurine sauropod dinosaur, which represents the smallest and only sauropod from the region. The remains found were incredibly fragmentary, with a few vertebra and leg bones uncovered. Enough data was collected from the bones to declare the creature Yamanosaurus lohiensis, a saltosaurian, which is a group of sauropods endemic to South America, known for armored hides akin to the ankylosaurian ornithischians of the Cretaceous period. When heads collide. Pterosaurus is not a primitive ankylosaurian dinosaur, but its anatomy is quite unlike most other members of the clade, with a tubular potato-shaped body, rather than the normal coffee table platform shield of the nodosaurs and ankylosaurids. Its skull is a rounded square with large eyes and nostrils. 3 new specimens of the genus have been prepared and described, which gives an improved image of the group's skulls, and suggests Pterosaurus and its contemporary ankylosaurid cousins were in a relationship of niche partitioning. The snout of Pterosaurus suggests it may have been a grazer, while the snout of the contemporary Sauguntegia is thought to have been used for browsing. Fault lines between dinosaurs. At some point in the evolution of theropod dinosaurs, the group of theropods called Tetanurans split up into 3 clades, the Coelurosauria, Megalosauroidea, and Allosauroidea. Obviously, it would be impossible to get an exact time frame as to when this occurred, but the general start and stop suggest it occurred sometime during the early Jurassic period. Early members of these Tetanuran clades exist, but are rare. Each new data point provides more steps along the diversification of these theropod predators. A new partial skeleton has been described as Asphaltovenator vialdati, and it represents a missing link, if you will, between the allosauroids and the megalosauroids. The fossils show characteristics of the allosaurs and the megalosaurs, and connects these 2 lineages together during the early to mid-Jurassic period. The Mother in the Tree. The Varanopids were a group of possible synapsids related to the true Pelecosaurs, like Dimetrodon and Edaphosaurus, but with much more basal characteristics and an appearance and lifestyle probably somewhat similar to the modern monitor lizards for which they are named. A new Varanopid synapsid was described based on 2 partial skeletons of an adult and juvenile, and they were named Dendromya unamachiensis. The fossils of Dendromya are suggested to possibly represent a parent and offspring sheltering together before death, and thus would represent some of the earliest instances of parental care, adding more data to the diversification in parental care amongst pre-mammalian synapsids. Previously, the Varanopids have been considered either synapsids or diapsids. The evidence used to determine this may be faulty, as the fossils of the juvenile Dendromya were very similar to the anatomy of some of the Varanopids used to place the group within the diapsid basket, which means those species known from baby-like anatomy may be babies of larger adult Varanopids, with anatomy more akin to the synapsid label that had been placed on the group prior.
Unfortunately, that concludes this year's PaleoRewind for 2019. The end of a decade. The last 10 years have seen a great many discoveries and changes in the study of prehistoric life. And the decade to come will further enlighten us as to how we fit into that story of life. The cast of PaleoRewind will exchange new channels to introduce you to some of their voices, personalities, and styles, and I can't wait to see how that will change next year's Rewind. I had to exclude a great many entries on the list of discoveries for the last year, for listing them all would have made this video far too long. If your favorite discovery of this year was not included, don't worry. I want to put together something that does list them all, but I've yet to work it out. I also want to put something together as a PaleoRewind of the decade, but you'll just have to wait and see. From the Edge family to yours, I hope you had a great set of holidays and a happy new year.